There are a few cases, other than for H, in which the octet rule is violated. Of course, with hydrogen, hydrogen only has 2 electrons around it. The exceptions are, first, particles with an odd number of valence electrons. These 3 molecules, for example, all have an odd number of valence electrons. We saw that in an earlier lesson, with regard to resonance, the Lewis structure idea breaks down a bit when we deal with resonance, and the Lewis structure model breaks down here whenever you have particles with an odd number of valence electrons. You can't draw an octet for one or more of these atoms whenever you have an odd number of valence electrons. This is a limitation of the Lewis model, not a limitation of nature. Nature does what it wants. The Lewis structure model works quite well in many cases, but not here. Another exception to the octet rule is for something like boron. Boron trihalides end up with only 6 electrons around boron. In general, I think it's a good idea to memorize that boron anything, trichloride, trifluoride, tribromide, always ends up with 6 electrons around boron. And thirdly, some atoms get more than an octet. If you have some room in the margin, if you're taking notes on this, you might want to jot this down, that more than an octet is possible only for interior atoms in periods 3, 4, 5, and so on. In other words, in a molecule, if the atom is an interior atom and it's in periods 3 or 4 or higher, it might be able to have more than an octet. Exterior atoms never do. Atoms in periods 1 or 2 never do. More than an octet occurs when an atom gains an expanded valence shell. For example, this molecule here, PCl5, if we count up valence electrons, chlorine has 7. 7 times 5 is 35, plus phosphorus has another 5, so that's 40. When you draw a Lewis structure for this, and this is the correct Lewis structure, you will see that phosphorus has a total of 10 electrons around it, not 8. This is one of those cases where the octet rule is violated. Here are some other examples. We got a couple of ions here. Feel free to write those down and draw out the Lewis structures and convince yourself that in each case the central atom has more than an octet. As we noted earlier, expanded valence shells occur only for atoms in periods 3 or higher. There's speculation that unfilled d orbitals might be involved. I think that's a bit up in the air as of 2016. In any case, the reason that atoms only in periods 3 or higher can have more than an octet is because the central atom has to be big enough to accept additional electron pairs beyond the octet. This works best with small exterior atoms because they fit more easily around a larger central atom. For example, if we had to guess with golf ball versus a baseball, which would we put in the middle, which would we put on the outside such that we could put the most atoms on the outside? And the answer would be you'd put the baseball in the middle because you could get many golf balls around the outside of that because the golf balls are smaller. You put the golf ball in the middle, you can't get very many baseballs around it because the central atom is simply too small. Final thoughts on exceptions to the octet rule. Exceptions to the octet rule can occur in 3 cases. A. There's an odd number of valence electrons in the species, and there are a few examples. B. Species having less than an octet, for example boron trihalides, only have 6 electrons around the boron. And C. Species having more than an octet. This is possible only if the central atom is in period 3 or higher. In this diagram on the right, I've shown that the atoms in period 2 are not eligible to have an expanded octet, but the ones in periods 3 and 4 and so on potentially could.